Hello everyone, I am Pooja Shirshikar and today we are going to see congestion prevention policies. Okay. Before seeing congestion control, let's understand about what is congestion. So congestion is nothing but traffic in a network. So congestion is occur when load on network is greater than capacity of network. Means the capacity of network is very less and we are trying to send number of packets in more number, so it may be create a congestion. So imagine in a highway with too many cars, so because of this they slow down or maybe chances of accident. So similarly in a computer network, if too many packets are sending through a link or node, so it can become congested. So because of congestion, so there is a chances of packet losing and it lead to delay, and the overall data transfer rate can be significantly reduced, and this also impact on application performance. So for that there is a congestion control techniques. So congestion control is a mechanism so that prevent a network overload. So because as I said, because of network there is a chances of losing data or the slow of speed delay, so which is negatively impact on user experience. So for that we have to control the congestion to ensure efficiency data transmission even under heavy network load. So there are mainly two congestion control technique, that is open loop congestion control and closed loop congestion control. So first open loop congestion control. So open loop congestion control policy are applied to prevent congestion before it happen. Means it mainly focus in managing the flow of data that source and at the source and destination rather than reacting to congestion after it happen. So there are different policies, so like transmission policy, admission policy, discarding policy, acknowledgement policy and admission policy. So let's see in detail. So first is a transmission policy. So it is a policy in which transmission of data packet are taken off. So if a sender feel that packet are get lost or corrupted, so sender retransmit that packet in a network. So means sender is send the packet to receiver side, and sender is feel that because of any problem the packet are not received successfully in receiver side, so then sender will resend those packet. So because if this there is a chances of creating a congestion. To avoid a congestion, transmission timer must be designed in this way to avoid a congestion, and it's also able to optimize a efficiency. So next, window policy. So in a window policy there are two methods, go back and window and selective repeat window. Selective repeat window is very beneficial because in selective window it should be adopted and it send the specific packet that may have been lost. Means in a selective repeat window policy, if a sender get acknowledgement of the packet, and if he not get acknowledgement of some packet, so it resend only those packet which packet acknowledgement he not get. So means it not send all packet again, it sends some specific packets only. But in a go back and window, it resend the all packets again even if the receiver side packets are successfully reached. So this is nothing but window policy. And third is a discarding policy. So this is very interesting. So in a so as a name discarding policy, so router will discard the packets. But which packet router discard? So it discard those packet which have a less which packets has less sensitive. Means a router is trying to discard the packet so which has less sensitive packet, so without affecting the content. For example, you are sending a file, so you are sending a audio file in a, and you are divide that audio file in number of packets, and there in some packet there is a noise, or the information, some packets are not contain the sensitive information, so that less sensitive packet router discard to ensure the quality. So by using discarding policy, we can prevent the congestion, means we can discard the packet which has less sensitive, and we also maintain the quality of packets. So this is nothing but discarding policy. And fourth is acknowledgement policy. So as I said, when receiver receive the packet, so it send a acknowledgement. If sender send for example, if sender send 10 data packets and receiver send acknowledgement for that all packets, for example, the receiver send acknowledgement for n packet. So because of sending acknowledgement for every packet, so it create a congestion in a network. To avoid a congestion, so receiver send acknowledgement for set of packet. If he received the 10 packet, so for that he send only one acknowledgement. So by this way we can prevent a congestion in a network. And fifth is admission policy. So in a admission policy, to avoid a congestion in virtual connection is used, because in this approach router is set up a path between source and receiver. So it's set up establish a fixed path before sending a packet, and router is trying to accept the request or request to reserve the source from that packet that is in setup phase. And if router predict that there is a congestion in a path or a network, then router will not admit that request, and itself it it reject that request. So instead of facing the congestion in a future, it trying to stop it's trying to stop request itself in very beginning. So by this way we also prevent the congestion. And so this is very important, congestion control policies, means admission policy. By this way we can prevent further congestion by using the virtual network connection. And second type of congestion control is closed loop congestion control. So closed loop congestion control technique are used to treat congestion after it happen, means after congestion is occurred, how to control. So there are some techniques are used to control congestion and to avoid the congestion. So first is back pressure, second is choke packet technique, third is implicit signaling, and fourth is explicit signaling. So first is back pressure. So back pressure is a technique in which congested node stop receiving packet from upstream node. Okay. So here you can see, so this is a sender and here is a receiver, and in between there is a number of router, and assume that the third router is experiencing a congestion, then it send a request to second router to slow down sending packet, because third router is facing congestion. It unable to process the packet, so there are many packet to get processed. So because of this, third router is facing congestion, so it send request to the second router, and second router send that same request to first router, that he are facing congestion and slow down the sending packet, and first router send this request to sender. So as you can see, in a backward direction the information is sending. So this is nothing but back pressure. And second technique is choke packet technique. So choke packet technique is applicable for both virtual network and datagram. So here you can see, so it is a destination and it is, here is a source, and in network there is a number of router, and third router is facing congestion. So this router is directly sending message to sender that he is facing a congestion and slow down a sending packet. So in a back pressure, it's sending message to upstream, and then again this router is sending information to next upstream router, then it go to sender side. But in a choke packet technique, it directly sending that information to sender, but it's sending this information by using a special packet. So that is nothing but choke packet. So by using choke packet, it's sending information to sender side. So let's see next technique. So third is implicit signaling. So in implicit signaling, there is a no connection between congested node and the source. So in implicit signaling, there is a no communication between sender side and receiver side. So obviously sender will not get any acknowledgement from receiver side. So sender feel like there is because of any problem the packet are not received in receiver side. So sender will resend that packet to receiver side. So because of this, there is a chances to create a congestion, means sender feel that packet are get lost and it not received receiver side successfully. So it resend again that all packet to receiver side, even if that packet are already received in server side. So because of this, there is a chances to create a congestion. And fourth technique is explicit signaling. So in explicit signaling, so here is a sender and here is a receiver. So in a network there is a number of router, and router third is facing congestion. So in explicit signaling, router third is directly send information to sender to slow down sending packet. So here you see that, so in a choke packet we it also sending directly information to sender to slow down. But in a choke packet we are using the special packet, that is choke packet. By using choke packet we are sending information to sender, but in explicit signaling we are not using any special packet. By using data packet we are sending the information, means which data packet he received. So by using those packet we are sending information to sender side to slow down sending message. In explicit signaling there are two methods, forward signaling and backward signaling. So in a forward signaling, signal is means the information is sending in forward direction, means if any router is facing, here is sender and here is receiver, and they in a transfer there is a number of router, and third router or second router is facing congestion, but it send this information in receiver side means it the destination side it informing that there is a congestion, and in backward signaling it sending information to sender side. So in a backward direction it's sending the information.